Hello everyone, welcome back to my channel. Okay, in this topic, the new topic, we're going to talk about new technologies applied to data warehousing, as we already discussed about workload management in the previous video. So we just going to focus on the technologies in this topic. Alright, let's starting with the contents of this topic first. Okay, first there are four subtopics in this chapter. Okay, we're going to discuss about three technologies in the data warehouse, which are data warehouse appliance, cloud computing, and data visualization. Okay, before we discuss on these three technologies, we're going to start with uh, challenges in this data warehouse, where we already discussed in the previous video, and this is just some sort of revision. Okay, we're going to start with that first. Right, data warehouse challenges which have already been discussed before. Okay, just revisited. Okay, first of all, we're going to talk about speed. Okay, speed is a very important measurement. It's a define the success of data warehouse in the real world. It is also the measurement is used to measure the efficiency and effectiveness of data warehouse. Okay, this is include both inbound and outbound sites, which I already explained to you in the workload management video. Okay, also besides speed, there are another challenges which are what we're going to focus in here in this topic is performance and capability in data warehouse. Okay, this is the highlighted word. Okay, there are 6 key challenges that involving this performance and capability. Okay, they are listed here. First one is data loading, and then data availability, data volume, storage performance, query performance, and lastly data transport. Okay, we going to go one by one. Okay, data loading will be discussed later, okay, because there are a lot of another issue under this data loading. Okay, about the availability. Okay, availability is the availability of data. Okay, this has been a challenge in the data warehouse. Okay, due to the loading process and the infrastructure as a whole. Okay, the non-availability of timely data has impacted the usage and adoption of the data warehouse within the enterprise. There are several reasons for data to not be available in a timely manner, including the lack of documented requirements, and the underestimated data growth projection, data demand projection, data retention cycle, and associated query response service level agreement, which is known as SLA in short. Okay, that's why is the reason why data is not available. Okay, that is one of the key challenges. Okay, then we have data volume. This will be going to explain in details in the next slide because there are some issues under that. Okay, then we go to the storage performance. Okay, storage performance is a big area for the data warehouse. The issue here is both at the data architecture and storage architecture areas. The sharing storage across all areas of data warehouse infrastructure creates a huge penalty on both the ability and performance of the input-output system. Okay, so it's not much about storage. Okay, we take a look about the query performance. Okay, the queries that cause the most impact are ad hoc queries, analytical queries. Okay, these are due to their non-deterministic nature. The queries can require a small but wide data set that needs access to multiple areas of the storage, or a large data set that can be accessed in a smaller storage area. Okay, ideal situation, the impact of the query is including the moving it across the network impacts the overall performance of the query lah. Okay, last one is data transport. Okay, this is a major processing overhead in the data architecture. Okay, because the transportation of data from layer to layer and its subsequent availability for processing lah. Okay, this overhead is not often noticed or calculated as it is assumed to be a part of the bandwidth issue in the network or the capability limitation of the memory or disk architecture. Okay, let's take a look at data loading and data volumes. Okay, about data loading. What is a data loading? It is a process that can range from simple to extremely complex. Sorry, to extremely complex. Loading of data to the data warehouse has been a design challenge for the longest time. There are 5 issues, but I combine master data, metadata here. Okay, so we start with the first issue, which is data quality. Okay, this is one of the biggest bottlenecks in processing data from source database to staging or IDS or a data warehouse. Okay, the data quality processing. Okay, and then slowly changing dimensional data. Okay, this processing slowly changing data to the data warehouse is often a key area to verify performance. Okay, this type of processing involves several layers of hidden complexity from reference data, facts, keys, referential integrity, maintaining history, and if there is partitioning involved, with either the update date or any specific data that changes as a dimension, moving the data across storage segment and such. Okay, this is also another key for performance management. And then we have master data and metadata. In master data management, this a key of challenge for the data warehouse, and then for metadata is the challenge is the maintenance. Okay, the maintenance of metadata is often to be overlooked in the data warehouse. And the last one is transformation and processing. Okay, the data transformation and processing business in business rules involve several complexities across different stages in data management layers of the data warehouse. Okay, these transformation rules often add layers of processing that may not be needed but are created to overcome shortcomings of the current architecture of the data or the platform. Okay, this is another area of huge opportunity to improve efficiency in the data warehouse, data transformation and processing. Okay, next we going to discuss another last one. Okay, the data volume. Okay, where data volume in the data warehouse has been growing at an explosive rate of several terabytes per day. Okay, why the data volume has been increased? Because the analytics. Okay, and then because of the compliance requirements. Okay, and then because of the legal requirements, because of data security, because of business users, because of social media. So social media is has you see the trend of data volume in the social media has been impacted very much. I think in this one. Okay, you know about that because we all use social media every day, and the last one is non-specific requirements. Okay, that's all the data challenges. That's all the challenges that we um, that has been discussed, okay, in the data warehouse. Okay, now let's talk about the technologies. We start with the first one, data warehouse appliance, which in short is a DWA. Okay, what is a data warehouse appliance in short? Okay, a data warehouse appliance is a standalone set of hardware, so it's separate. It servers, memory, storage, input-output channels, all separate. It's a plug and play. Okay, it's loaded with an operating system, database management system, and administrative tools designed to support a multi-node database deployment. Okay, they were sold as a self-contained unit that could be installed in data center. Came pre-configured for redundancy and high availability, and often included service and support from the vendor that manufacture them. Okay, this is a definition of the DWA. Okay, later on, at the end of this discussion about the data warehouse appliance, you can see that this technology is already dying. Okay, why? Because of the separate of set of hardware. This is why. Okay, and also another reason which we'll be going to discuss later. Okay, because we are using the 2013 workbook. Okay, so the data warehouse appliance is quite new during that time and has been discussed in this syllabus, but it has been dying. this technology because of the cloud computing, the second technology that we're going to be discussed later. After all, we just going to take a look what is this technology. A little bit history on the DWA. The first commercial that DWA was introduced by Niteza. This company is now part of IBM. Was introduced in 2001. Even though Teradata has been designed this DWA, the conceptual design, the architecture of the appliance was done by Teradata lah. And then this was soon followed by Greenplum. Now the name is EMC. I'm not sure if they are changing the name again or still EMC. Oracle, Vertica. Vertica is a part of HP now. Data Allegro, part of Microsoft. And then Teradata, Stdata, now part of Teradata. Parallel, Keepfire, which is also part of Teradata, Cognitio, Extreme Data, Infobright, and others. So there's a lot of company involved in these technologies. So the primary design goals of the DWA are to overcome the bottlenecks caused by shared everything approaches, and to ensure all this, that means it has to overcome scalability, reliability, fault tolerance, self-managing and tuning, and also the last one is to lower costs of entry and sustain managed costs. The underlying architecture tenets of the DWA include shared nothing architecture because it's not using the shared everything, so it is based on the shared nothing architecture. Commodity hardware and storage, massively parallel processing engines, and also workload optimizers. This is the generic appliance architecture. So the separate things. This one is connected to master node. So it's a interconnect switch between the separate system. The advantages of this architecture. All the data is stored locally across the nodes, and each node manages its portion of data and query assigned to it by the master nodes. Data is striped and mirrored across two nodes at a minimum. This will increase the scalability when the large query workloads are submitted. The advantage of data being mirrored is that it helps in achieving workload balance and can support failure in case of an unplanned outage. Fault tolerance. When the need arises for scalability, the nodes can be used to divide the work in discrete chunks, and if needed, we can simply add more nodes that can be configured and used by the system with minimal intervention. And lastly, a node can be assigned a specific role or set of roles to be available for querying, loading, and managing data. So there are 5 advantages here of this architecture. This one is a data distribution in the appliance. For data distribution in the appliance, what designer architect need to do with this type of data layout? So they need to understand the data and special requirement for handling data, understand the underlying relationship, and understand the data skew, data volume, and data groups in order to do the design, the data distribution in the appliance, the WA. Right. So what is the advantages of this data distribution? The data variety is in more than one storage location. The optimization of the workload to execute on non-computing infrastructure, the minimal amount of data movement within the infrastructure, fault tolerance, the ability to dedicate resources across nodes on the field to accommodate completion of tasks, and node balancing. There are 10 keys that has been practiced for deploying a DWA. First is clearly documented requirements in terms of data availability, data scalability, query analytics, performance security, compression, data growth, and mix workload. and then implementation architecture, data architecture, workload architecture, security architecture, all these type of architecture, and then compression, proof of concept, BIA tools integration, analytical function, and data loading. So you need all these 10 key lah in order to practice, in order to get the best practice for deploying a DWA. Okay, the advantages of DWA, it is a complete black box architecture built for the data warehouse and its application, redundancy and support for fault tolerance, minimal user intervention needed for operation, modular infrastructure scalability, lower capital expenses, okay, capex cost when compared to traditional infrastructure costs. Okay, it is lower if you compare to the traditional. Okay, if you compare to the cloud, I think DWA is more expensive. Okay, higher ROI and reuse of skills and personnel. Okay, this the issue that I talked about early of the DWA introduction. Okay, one of the blog stated that data warehouse appliance are becoming history. Okay, and this blog is written in 2020, and now it's 2021. So I'm pretty sure. I'm not very sure what happened to the data warehouse appliance, but I'm pretty sure it's becoming more let's say less user that use this technology lah. Because most of company began to use cloud computing, which we're going to discuss later on. Okay, from the blog. Okay, from this website. Okay, it stated that data warehouse appliance did an excellent job on solving data warehouse scaling problem in the early 20s for companies that wanted to run enterprise scale analytics on their OLTP dataset, but didn't want to design, build, or operate data warehouse infrastructure themselves. Okay, so this DWA, it gave the companies ready to install solution instead of box of parts, which some assembly required. Okay, the challenges with this system is that they were expensive. So I already told you that it's expensive to acquire and costly to operate. And then scaling via hardware isn't something that can be done quickly. There are lead times to procure, so it's also take times. Okay, install and configure new equipment, and capacity increases couldn't be met in small increments, meaning companies often had to purchase in advance capacity that they wouldn't need for a few quarters. So it's such a waste. Right, so the base option in the market, the companies were happy to have data DWA available as the time to value was faster than the do it yourself approach. That's the challenge lah, for DWA. So we're going to discuss the next technology, which is cloud computing. So the next one is the cloud computing. I think most of you are already familiar with this term, cloud computing. You actually might use it in your everyday life, but sometimes you did not realize this is a part of technology that are very useful in our everyday life. Okay, there's a few type of cloud computing here: private cloud, public cloud, hybrid cloud, and I think most of you are familiar with the terms like Google Cloud, Microsoft Cloud, and other cloud platform. Okay, the cloud computing is not just a platform. Okay, it's not just a platform to you save your data, save your file. It's not just a database. It's also an applications, mobile, storage, and server. Okay, let's take a look at definition on the cloud computing. If you Google what is cloud computing, there is actually a lot of result that showed there is amongst others definition, but it's actually will come up with the same definition eventually, which is if we are just shut it up and make it simple, cloud computing is the delivery of different services through the internet. So that is the most, I think, so far shortest explanation that can be explained here. Okay, about the cloud computing, so it's a different services. It's not just an application. It's anything service. Okay, like data storage, servers, databases, networking, and software. Okay, rather than keeping files on a proprietary hard drive or local storage device, cloud-based storage makes it possible to save them to a remote database. Okay, that's another definition of cloud computing. That means it's on your network. Okay, it's not in your hard drive or local storage device. It's something on the internet. That is a cloud-based storage. Okay, as long as an electronic device has access to the web or access to the internet, it has access to the data and software to program to run it. That's what is a computing for a simple explanation. Okay, then there are few benefits of cloud computing. Okay, first one, obviously it can be accessed from anywhere in the world, but might be have to edit as long as you have the internet connection with it. Okay, so you cannot access it although you are anywhere from the world, but you cannot access it without the internet. So internet is very important for the cloud computing. Okay, also it reduces business latencies when developing or testing application. It also can simplify and reduce process complexities in a more simple things. Okay, and then abstracts of the complexity of underlying infrastructure and creates simple plug and play architecture. Okay, SD is actually similar with the previous point here. It's a simple application. It does not require you to determine the size of the footprint when you initially deploy a development process. Okay, and then it can provide an adequately secure environment and also provide you a complete platform and free site to keep the business running. And lastly, it provides you with an option to conduct experiment on a small footprints on a mission critical and secure infrastructure. So all these are the benefits of using cloud computing. Okay, there are three actually types of cloud computing. Maybe you just know like Apple Cloud, Microsoft, IBM Cloud, but they are actually different types. There are three here. Okay, first of all, is a software as a service, we short as a SaaS, and then we have infrastructure as a service, IaaS, and platform as a service, PaaS. Okay, for the software as a service, it involves the licensure of a software application to customers. The is license typically provide through as a pay as you go. I think most of the uh, cloud computing available now is a pay as you go, but the software the the simple example for this type of cloud computing is of course Microsoft Office 365. Okay, then we have infrastructure as a service. Okay, this involves a method for delivering everything from operating system to servers and storage through IP-based connectivity as part of an on-demand service. So this the simple the I think obvious example is IBM Cloud and Microsoft Azure. Uh, if you are the Azure user, so you know that you can do anything inside the cloud. You can do the data management, you can do machine learning, everything infrastructure available in the cloud. Okay, I think AWS also part of the example. Okay, and then we have platform as a service. Okay, this is the most complex of the three layers of cloud-based computing. Okay, it is similar with software as a service, but the different is in this platform service, instead of delivering software online, it's actually a platform for creating software. So it is more complicated. It's not just like plug and play like the first one. Okay, so the example here is Salesforce.com and Heroku. Okay, this is a cloud computing components. Here we have a management services, business application and service, platform service, and infrastructure service. Okay, same with the types. Okay, and then for cloud infrastructure, we have application services, storage, hardware, and visualization, operating system tools. Okay, the infrastructure involving application. So there are like services, for example, like PayPal or Google Maps. Okay, it falls into this category. And then for business, Salesforce.com and Microsoft 365 is under business. Okay, and then collaboration like forums and mobile application. I think this is like more to Apple Cloud. Okay, and then services. Okay, the services include the different management tools and software API layers for program and deployment. Okay, then we have storage. I think storage is very famous in the cloud computing. Okay, you have Dropbox, Google Cloud, and then you have everything inside your cloud storage. Okay, and then hardware, and the last one is visualization. This all the infrastructure in the cloud. Okay, benefit of cloud computing for data warehouse. What are the benefits? Okay, there are 5 here. Infrastructure spending is not capital investment. Scalability is managed by the provider, so you don't have to worry about the scalability. And then utility-based spending provides better budget management. And then quick deployment, increasing time to value. So it is safe. It is less cost and time saving. And last one is reusable components. Okay, although with all this benefit, there are also issues, okay, that are facing cloud computing for data warehouse. Okay, first of all, workload management is not flexible as resources are shared and managed. Okay, and then the data access from an user perspective required overhead. Also, the performance management is driven by tier and class of service. Lastly, high volume of data movement to and from the cloud is non-secure environment violates compliance requirements. I think I'm not sure about some issues that might be solved by now. Okay, anyway, we're going to discuss the last one, the last technologies involving data warehouse, which is data visualization. That will be in the next video, not in this video. Okay, this video until this part only. So I see you in the second part of this data warehouse technology in the second video. Alright, thank you for watching.